This video will explain the basic truth table for biconditionals. The basic truth table for biconditionals is pretty easy, but it can be a little weird also. So I'm going to do something that will help explain that. But first I'm just going to give you the truth table. So the statement P double arrow Q is true when either P is true, when P and Q are both true, or when P and Q are both false. Now that part may seem pretty strange, that last part. I will show why this is in a second. And then it's going to be false on every other row. So the thing to keep in mind for the biconditional is that it's true when both sides of the biconditional have the same truth value, and otherwise it's false. Why is this? Well, recall when we talked about translating biconditionals, I said, well, that's really just a shorthand. The P double arrow Q is a shorthand way of saying if P then Q, and if Q then P. So let's do the truth table. So these two formulas are logically equivalent. They're the same formula. So let's do the truth table for P arrow Q and Q arrow P, and that will show why the truth table is the way it is for P double arrow Q. So first let's do the truth values for just the P arrow Q part. So P arrow Q is going to be false when P is true and Q is false. So I'm going to use a lowercase f here. And on every other line, it's true. Okay, and then Q arrow P is going to be false when Q is true and P is false. So that's the second line. So it's going to be false here. And it's going to be true on every other line. Then we can use the truth table for AND to figure out the truth table of the formula as a whole. So when P arrow Q and Q arrow P are true, well then P arrow Q and Q arrow P is true. At the next line, we have true and false, so that's going to be false. And then we have false and true, so that will also be false. And then at the last line, we have true and true again, so that will be true. So cross these out, because we don't need those anymore. We could even, let's erase them. That will look neater. Then we see that the truth tables are an exact match. On every line they're the same. So where P double arrow Q is true, P arrow Q and Q arrow P is also true because they're logically equivalent formulas. And that shows why the P double arrow Q has sort of the weird setup that it does.